Hi, sixth grade, and welcome to our weekly recap of everything we learned this week. So, just like the week prior, we are going to just review some of the key concepts that we've learned this week about acceleration. So, join me as we go through this slideshow. So, we're going to make this pretty quick today. Starting off with our first slide here this is the question that we were asking this week. We were asking, what happens when your speed changes? So the week prior, we learned about speed. Now we're learning what happens when it changes. What happens when you slow down or when you speed up? Now, Mr. Francina, again, took you through the first 2 days, and he told you that acceleration, lowercase a, is how much your velocity or speed changes in a period of time. He also said that in order to determine acceleration, you need to know two things: the change in speed and the elapsed time. And over on the right are just a couple of snapshots from the YouTube video. Go check it out if you're a little foggy on what he was talking about those days. All right, that's the best review. Now, he went further and had this awesome little screen clip montage that I had to take a screenshot of. He went further in telling you how you can actually calculate how fast something is speeding up or slowing down. So what did he go on to say? Before we get into that, let's go over the key vocab for this week. So number one, acceleration. We already talked about that. Number two, it's delta. Remember, that means change. So delta V is the change in velocity or speed. This is very important with acceleration, right? You need to to find the change in speed, you need to take the initial speed minus the final speed. Not final minus initial, initial minus final. The starting speed minus final speed. And finally, triangle T is still the same. It's still the change in time. Now, he went on to say that the equation for finding out speed is triangle V, change in speed, divided by time equals acceleration. And here's an example of one of the problems that he did. Now, notice some of his answers were positive and then others were negative. So remember, if you end up with a positive number, that means that you are speeding up, right? You are gaining distance per time. If you get a negative acceleration, that's technically called slowing down, right? So that's kind of a weird word, right? Negative acceleration. That just simply means you're slowing down. So negative, that indicates you're slowing down. Positive indicates you're speeding up. Again, we have a triangle trick for acceleration. So hopefully it was a little easier for you this week because you already know kind of how the triangle works. Only now we have acceleration, change in speed, and time. It just looks a little bit different. So again, the steps, nothing has really changed. In order to do these problems, as hopefully you've been doing this week, all you need to do is first read the problem, then determine what the problem wants you to find. Use the triangle to determine the equation. Remember, you would cover up, the one that you're trying to find. So if I'm trying to find acceleration, I'm left with triangle V over T, so on and so forth. Then you go back to the problem, find the other components, and finally solve and label. And remember, units matter. So everything in acceleration is going to be squared. And Mr. Francina tells you why in the YouTube video. For example, it's not meters per second, that's speed. It would be meters per second squared for acceleration. As always, take a pulse check on yourself. How are you feeling this week? Acceleration is a little bit different, but it's a lot of the same of speed. So it's same triangle, same equations, a little bit of math. Are you code green, yellow, or red? Always, always, always reach out to us if you have questions or concerns. And we're here for you, right? We're on your side, and we want you to succeed and to continue on with the content. So if you're stumbling, reach out to us, and we'd love to help you. All right, take care, sixth grade.